joining us today for our very first detection engineering dispatch. This is a bi-weekly live session, so you'll be invited bi-weekly to join us. We'll be talking about best practices for detection engineering. We'll be going over some trending threats and topics that might be top of mind for you. We'll also have hands-on experience and workshops some weeks. We'll also be bringing on some really awesome people from the industry and detection engineers to talk about their learnings and best practices, fireside chats from all of them, as well as Q&A from all of you with, just an open conversation around your environment, your experience, just to really help tune your skills and build a community of detection engineers and like-minded individuals that are working in the SOC. So even if you're not a detection engineer, please bring your friends. You're welcome. We'll be talking about a lot of different things. We'll be going over some PowerShell in the next couple of weeks and doing some hands-on workshop so stay tuned to those bi-weeklies. And in today's session, we have Tim Frazier, who's going to be doing a 20-minute walkthrough on Detection Engineering 101, specifically for Splunk users. Welcome, Tim.
Oh, thanks, Jade. It's great to be here today. How is everybody? I just thought I would take a few minutes and give everybody a primer on my favorite topic, detection engineering. Hope you're all ready for that, because I'm ready. You think they're ready, Jade?
I'm ready. And if everyone else is ready on the call, don't forget there's the Q&A chat on the bottom. You can also just chat directly and down below. And at the end, we'll make sure to open it up for about 5 to 10 minutes of Q&A for any questions anyone has.
Awesome. Thanks. Yeah, please do. We'd love to make this interactive. The only other thing that I need to do before I get started is I need to have somebody bring me a little bit of water here. You could go ahead. Oh, thanks. Appreciate that. Yeah, I know he's a great guy. I love him. He really helps me out a lot around here. So, all right, enough of that. Let's get into what is detection engineering and actually talk through that. So before I do that, I have to give a quick note that if you would rather do something else besides listen to me and my groany jokes, you can always go to anvilogic.com/test drive and actually try this out yourself. We have the ability to get in our product and do some cool stuff. But, that's all I'll say about that. We'll revisit that at the end. Let's talk about our agenda for today. I'm going to do a quick introduction. We're going to do a definition and evolution of detection engineering. We'll actually get through a step-by-step walkthrough and give you an afterthought or two, and then we'll hit some Q&A. So let me actually put this over here so that I can look at it while I'm looking at you all. All right, so introduction. I think this is relevant. Besides walking in and looking at my bookshelf, you might actually want to know a little bit more about me. I've been doing this for over 15 years. I like to think of myself as a conceptual thinker who wants to be practical. I started out in the Army doing net ops and information assurance, spent some time consulting, hands-on practitioner work, building out a security operations center, doing extensive work around SOAR and then SIM, cloud security. So been doing a lot of different things, seen what works and what doesn't, been through many different, what's that cycle? Cycle of hype and disillusionment. I can't remember, there's a technical term for it, but it is a thing. Now, one thing I would like to do by way of participation is just ask if anybody could actually, if you could just put in the chat box and, what your role is. And on a scale of 1 to 5, how comfortable are you with detection engineering already, right? And kind of the way to gauge that would be, if I were to ask you to detect APT29 in your environment, would you know where to start and what to do for that? You don't have to put all that in the chat box, obviously just a number on a scale of 1 to 5, but thinking through that process, if you feel comfortable with that, that would be on the higher end of the scale. So would love to just kind of get a sense of who's out there. And while you're thinking about that, we're going to move on to the definition. Now, definitions are important. If you don't think so, just ask Michael Scott. One letter can make the difference between a welding toast and a wedding toast. So thank you for the courtesy chuckle, whoever that was. So the reality is that there's a lot of different definitions of detection engineering floating out there. I've tried to distill down some of the most important elements from my perspective and experience. I think, what you want to do is there's a variety of tasks that are part of it, but it's ultimately a holistic practice. And so what I kind of did is break it down into the steps and the things that you go through when, a detection life cycle, so to speak. So you can see it involves researching, building, testing, deploying, validating, and maintaining. And what are we doing that for? Rules, searches, and methods. What are the goal of that? Detecting adversarial or otherwise unwanted behaviors on your computer systems. So I think one thing I'll call out, right? We're not going to be able to get into the nitty gritty on every one of these things, obviously, today, but there's a lot of things to think about holistically. One of the things I do want to spend some time talking about is a method, though, right? When you're writing detection content, it's more than just writing a rule in a sim. There is actually needs to be an overarching framework and method to the madness in order to do that effectively. And so that's kind of leads me to the evolution of it, right? We think about the pyramid of pain that came out 10 years ago, right? This marks one of the 10-year anniversaries and came back in 2013. But this idea was that if you're basing your detections on IOCs, right, the indicators of compromise that are the hashes, the IP addresses, et cetera, it's very easy for the adversary to change those. So it doesn't cause them much pain in order to base your detections on that. And you're just playing whack-a-mole all the time. The ideal state is that we're detecting at the top of the pyramid, because that would be where it's very hard for adversaries to adjust. They're people ultimately just like us that have established processes, have established automations to do things in a certain way, following steps from one another. And so if you detect at that level, it becomes very hard for them to change, and it causes them a lot of pain, hence the pyramid of pain. Now, some of you may be channeling your inner Dwight out there and saying, oh, thanks, Tim, for presenting a 10-year-old idea and telling me about that. Yet once again, I got that from every conference talk that I've been to in the last 10 years. I hear you. I hear you. That's a fair criticism. So let's actually do the next step and build off of that by flipping the pyramid, which really just looks like an upside down triangle. And this one's for you, Jade, by the way. Why do triangles look down on circles? Because they're pointless.
Best dad joke ever. I love a good dad joke.
So back to the pyramids and triangles, what I'm talking about and how to actually do this is, rather than try to do either, you have one of two options historically, is you're doing, a search for a very specific thing on your raw data, and then that produces a lot of noise. It's going to produce a lot of output, and you're going to have to sit there and weed through all of that, baseline the environment, figure out what's benign activity versus what's actually malicious. And so it just takes a lot of work to get that right. The other alternative is to try to write some massively complex, really long search to look for multiple things at once, the old idea of correlation, that's just very difficult to do without massively using compute resources, or looking at too large a volume of data and just literally not being able to accomplish it. So what we're saying from a method perspective is you need to do this in two stages. You need to look for the interesting events first, and then store those in an intermediate location, and then you can actually do correlation against that data that's already been normalized, that's been tagged with the appropriate MITRE technique, et cetera. And ultimately that becomes a scenario. So, or I should say, ultimately that becomes a alert, which is the output of a scenario.
And Tim, what
yeah.
I'd love to know from people in the audience, maybe put it in the chat, how many people are actually solely looking mostly at IOCs, or maybe what's the percentage of simply IOCs versus sequential alerts that people are being able to get? Just pop it in the chat. It would be great to get an understanding of maybe who's already doing this versus is this something you're trying to do?
Yeah, no, good question. Would love to see thoughts there if somebody raises their hand on, yeah, we're doing this. All right. So another way to kind of think of this, right, or to kind of further explain it, is to go into an identifier. Would be looking at a very specific type of log event, looking for a specific event ID. In this example case, this could be looking for Windows event logs, event ID 4688, which is a process create, and then looking for run DLL 32, right? Or some way to load execution code via, a DLL, right? That would make up an event of interest. Then from a scenario perspective, we're looking for the ability to chain those events of interest together when they occur all on the same entity. So that could be a user you're correlating against that does all these things, the same host that they happen on. Maybe if you're thinking about the cloud, things that happen within the same cloud account. And then, of course, you're looking for time-bound connections in these events of interest. So you can set those thresholds accordingly to what you expect the adversaries to be doing, right? If it's an automated sequence of events or TTPs that they're following, then often those timeframes can be very short. If you expect it to be more of a manual process that they're following, those timeframes can extend out. So conceptually, that makes sense, right? I think everybody's kind of tracking on that, hopefully. But as you're well aware, this is not as simple as just drawing an owl, right? I love that meme too of the draw the first step, draw the circle, second step, draw the body, step 3, just draw the rest of the owl. All right, the goal of a detection engineer. Let's get into this from, as we think about this step by step, we're going to break it down. So before I do that, I would love to see if anybody has any thoughts on the goal of a detection engineer. I know I'm coming at you fast and furious, but we're trying to keep this quick and to the point. I have an idea that I'd love to share with you on this. The goal of a detection engineer is not just to write rules in a SIM, right? It's not just to write queries. It's to deliver actionable insights to analysts and responders. And I make that key distinction because actionable is kind of this barometer that we should be using more in security and detection engineering. A great example of this, right, is when people would try to create detections for activity external to the firewall, right? Now, this was a few years back when perimeters were much more common and cloud was less common. But the idea was that, hey, I want to, see if somebody's scanning me or doing recon activity from the external. And my response was, why? What are you going to do about it? What is the action that you're going to take if you're alerted to that activity? Some people were like, oh, we're just going to block it at the firewall. I was like, are you? Are you really going to spend that much time and effort trying to maintain a block list of external IP addresses that really just amount to scanners? Because anybody that's actively targeting you is not going to be coming from the same infrastructure or IP address that they're scanning is coming from. So anyway, the point of that is you need to understand and provide the necessary business and threat understanding as well as data understanding when you write this content so that your analysts and responders have the necessary context to make it actionable, right? If I look at this green dot on the slide here and I think about what is this, right? This is kind of typical of what analysts are presented with when a rule fires, right? They're just like, oh, here's a thing, here's a green dot. Now, if I zoom out and you see based on the context that this is a leaf on a tree, well, now you start to make sense of it, right? The dots start to line up as part of a bigger picture. You're given that business and threat understanding as well as the data understanding that's necessary for you to put that in context. So writing that content as a detection engineer, it's very important that you make the output of that actionable. All right, so let's dive into a little bit more about the analytics lifecycle. And I'm not going to get into the whole thing, right? That could be this topic of a whole nother session, but we're going to talk about collection and detection, and then the 3 steps below: research, develop, and maintain, which are part of that overall definition that I shared earlier. So the first step when you're thinking about researching, right, this is kind of where it starts. You're looking at what are the threats to my business? What would it look like in my business? How does it actually work? What would that translate into from a technical perspective? So that's kind of a threat modeling exercise that you should think about. What are the valuable assets? How would those be affected? And then you have to understand what sort of data would be necessary in order to identify that, right? If it's an external attack on our external facing web presence, am I collecting web logs? If it's a client-side attack that's potentially seeking to compromise a user endpoint, am I collecting that endpoint data, right? And so there's that aspect where when you're doing the research, you need to know what it is you're trying to look for in order to be effective at that. And then of course, getting the data prepared, right? Making sure that it's collectible at first at all, that is actually being collected into the SIM, and then that it's prepared accordingly and made available for detection against it. Now, the next part is actually developing it, right? So this is where we would be able to actually take our hypothesis, translate it into the nuts and bolts, right? The search language as appropriate. For the Splunk users out there, right, this would be SPL. For other platforms, this may be a different language. But then you have to actually evaluate it. So when you run that search, what do you get back? Do you get back exactly what you're looking for? Do you get back what you're looking for plus a lot of extra noise? And then again, is there something I can do to take action on this? If the next action you need to take is go search for something else with it, well, then maybe you need to think about combining those different searches together into an overall scenario. And then finally, how do you deploy that, right? How do you actually push that out into your environment, run on some schedule? Does your SIM or your search tool offer that as part of what it provides? And how do you maintain that in a large scale when you have many of those searches and potentially a distributed environment? So let's get a detailed example here when we think about Log4j, which hopefully doesn't send too many people into PTSD. So this was a multi-stage attack, right? There was several different things that you could look for in this, and just kind of breaking down a quick visual of the scenario. You've got where you're looking for somebody hitting your external web presence, and then you have a suspicious process spawned by Java, and then you have some sort of command and control activity. So in the first piece of this, right, we'd be looking for that potential external attack. I have a couple of links referenced here that I'm just going to pull up in the my web browser. I've already got these pulled up, but basically anytime a new threat comes out, right, or an existing threat that you maybe don't have a detection for, there's going to be a lot of research on it. And so it's your job as a detection engineer to kind of dive through this, find the relevant piece that matters. And what I've got here highlighted is an example of somebody testing this attack. And so what they're doing is they're actually making this call to a web presence, and this is the piece that you're actually going to care about, right? So being able to kind of take that research and translate it into a detection, that's part of the art of detection engineering, right? Is using that research. There's other things that people have done that provide, other ways to think about it. As you get into more detection, you'll realize that it's usually not as simple as looking for, just the kind of expected command name. You have a lot of obfuscation that adversaries are doing. So being able to look for obfuscated variants is important. So distilling that down, right, the essence of this is that we're looking at web traffic to find the string JNDI, right? We're trying to find any version of JNDI or obfuscated version of JNDI. So what that would look like is an example that some of our researchers and detection engineers have built is looking, and this is a Splunk SPL example, where they're looking at specific combinations of the JNDI string to be able to find that. So if I pull that up in search, right, we've got an example here in Splunk where we're looking for those specific terms, and then you'll see in the actual, WAF log or web log, right, the GET request that's actually hitting a specific endpoint, and then you've got the IP address that it's coming from, and then the JNDI piece that's basically initiating the callback. So again, that's just a quick example, right? I obviously kind of hand waved really quick at that process, but that's that first researching and developing, right? Finding the relevant articles, putting it into a search. Then you want to think about the next step, right? Which is the suspicious process spawned by Java. So I've got another article for that piece of it, where they actually go through and they break down the whole Log4j scenario, which was a great research article, right? If you want to get into threat research, that's another thing, but oftentimes that's the input to the detection engineering. Then one of the steps here that they're talking about is detecting a Java process that spawns an unusual child process. Okay, so we've got a list of potentially unusual child processes. So what that looks like, is you're doing process monitoring for a parent process Java plus a suspicious child process, right? So you're looking at your Windows event logs, perhaps like event code 4688, or you're looking at some other way that you're getting those, if they're XML or coming in a formatted way, and then you're looking for one of those suspicious child processes. So in a Splunk search language, that would show up something like this, and then you would see in the Windows event, you would see the creator process name, in this case was Java, and the process command line that actually executed was command.exe with PowerShell, and then this lovely encoded command, right? So again, those are the types of things you're looking for. Now, to kind of go back to this example, right, does every time somebody tried to hit my external interface and probe for this vulnerability mean that I was compromised? Spoiler, no, it doesn't. Does anytime some suspicious process spawned by Java mean that I've been compromised? No. But seeing both of those things together within 15 minutes and then seeing some sort of command and control within 60 minutes, now you have a very high degree of confidence that you have been compromised. So let's talk about maintenance, right? Now that we've kind of briefly gone over the research and development, how do you actually maintain these things at a large scale? That becomes very challenging without some sort of assistance, right? This is where we bring in automation, you bring in code management, source code control, right? These types of things. you have to be able to track that those things are still accurate, right? That they're still operating precisely. As you start to get those noisy things, how do you tune it, right? That's a big part of detection engineering, adding things to an allow list so that those are no longer part of your alert canon. And then, of course, making sure that those things maintain their actionability. Now, one thing, if you're really smart, is you won't have to keep documentation updated if you don't document anything to begin with. I am very guilty of this. I had a former boss that gave me the lack of documentation award at a previous job. So I can't say that this is a good thing, but it is something that happens a lot. So let's actually get into what it would be to maintain a alert. One thing that we've got here is looking for a malicious document execution. A lot of words on the screen, but this green search information here is just designed to detect when you have a Microsoft Office program searching or launching a command script interpreter as a child process. So when you're thinking about maintaining or adding to an allow list or documenting, you would want to actually go through and look at this, and in Splunk do something like a stats count by parent process name, by process name, and process, right? What this is going to get you is to be able to see those common combinations, right? Those common occurrences that happen all the time. You can do a stats count by user, stats count by host. These give you great insight into understanding things that are highly prevalent in your environment, which generally prevalence and malice are inversely related, right? When you're compromised in an organization, an adversary is going to move generally in a small number of instances. It takes them a while to compromise your entire domain, and usually they're not compromising all the individual boxes, they're going for certain select ones. So if you see a process that's running on literally all of your endpoints, well, it's unlikely that that's malicious, right? So the idea is that if you have, maybe this common occurrence in the whole accounting department, everybody runs this same macro in Excel that always launches a command script to do XYZ function that's part of their process, right? Okay, well, after you've looked at it and after you've determined that that thing that occurs a fair amount of times can be allow listed, then you don't have to revisit that, right? So these kind of things are ways to kind of look for hay that you can distribute and get rid of, and then way the needles become easier to stand out. Now, again, the idea of taking those things and putting it into a scenario, right? We talked about the individual things you're looking for, whether it's the two examples we talked about were the log4shell external attack and then the suspicious process spawned by Java. You've got to be able to put that into a scenario, and that's where having that method comes in so handy, where you're not necessarily outputting the results of those individual detections to the analyst queue, but you're outputting those into another index in Splunk or another database table, where you can actively take the time you need to go through and search for the combinations there against normalized data. So we're coming up on time, so I want to be sensitive to that and not take you guys down the line too long and give you a chance to ask some questions. But I think the reality is that we all face challenges around detection engineering. Usually those come in one of two forms, either capability or capacity. Capability challenge being, I don't know how, I lack the skills and experience. Capacity challenge being, I don't have the time to execute, even though I know what I need to do, right? And so you really, there's a lot of resources out there. There's some great folks in the industry that are publishing things on how to go about doing this. But I did want to share one other afterthought that's about as revolutionary as a bacon salad. We see a lot in the industry in cybersecurity in general about AI and ML, right? And ChatGPT has even exploded that kind of buzz that we see. I think the reality is we're starting to get to the point where that can actually be useful. I personally was very jaded towards AI and ML because a lot of vendors in the space, frankly, just come at you with, oh, well, we do this with AI, we do this with ML. And really, it's kind of an excuse to not have to explain what they do. But I think if you're talking to somebody who can actually explain why it helps and what it's doing, it can be a huge aid, right? I mean, I've been really blown away personally by the ChatGPT revolution and all the things that are available there and just the time savings that it brings. It's not a substitute, but it's an assistant, right? And so it brings us a lot faster, quicker to the places where we want to get. So that's kind of my 2 cents on that. again, if you haven't already been doing the test drive, hopefully you check that out later. It's a free thing. It's an automated sign up process. You don't have to talk to me or anybody else to get access to it, but I think it's interesting to check out. And that brings us to the wrap, and would love to take questions if anybody has any.
Yeah, I actually had a question come through, Tim. Can you explain a little bit about how you would, or if you have any suggestions on how to configure and optimize data ingestion in Splunk for this kind of effective detection engineering, or how do you do it in Anvilogic?
How do I optimize data ingestion in Splunk?
Ingestion of data into Splunk. Like, are we ingesting it into Anvilogic too? I think may be part of the question.
Yeah.
And then the configuration, obviously that is quite a bit of work.
It is. So. Yeah. So that's an interesting topic, right? It's a pretty large one, as a matter of fact. So you can get data into Splunk in a lot of ways, right? One of the things that you almost always should be thinking about is how do you normalize that data effectively? And, Splunk for a long time has published something called the Common Information Model, which is what everybody should be adhering to in order to get their data in the proper format. The reality is that can be hard, right? If there's not an app or a technical add-on, a TA, then it can require a lot of manual work within what we lovingly called props and transforms in the Splunk world, right? To make sure that that data comes in and it gets assigned into the right fields and they get extracted and all that fun stuff. I would say, there's a lot of detail work associated with that. One of the things about Anvilogic that we do differently is we don't require that. We don't require you to have it all parsed out and normalized ahead of time. We actually take care of that as part of that two-stage framework that I was talking about, where when we do our identifier searches, we actually do the normalization at that point. So we don't ingest data in Anvilogic, just to clarify that portion of it. It would still remain in Splunk, but optimizing it on the ingest, use the up-to-date TAs and add-ons as much as you can. If that doesn't exist, or you're struggling to get those proper field extractions, then you're either going to have to dive into the details of configuration files or get some assistance another way.
Perfect. If you guys have any other follow-up questions to that, let me know.
Otherwise, we can play flying horses again, and I can walk out the door.
Since this was a one-on-one, what can we expect? I think some people on the call are probably more interested in, or possibly also interested in, more technical advanced detection engineering details. If you can go into some of, what they can expect from, not just Anvilogic, but what we'll be going over for more advanced detection engineering.
Yeah, so I know, by way of sneak peek, I think you mentioned at the beginning, Jade, we have some stuff on PowerShell. We can get into, some of that process of writing detections. I know today, post session, we're actually going to be able to share with folks as a freebie examples of some detections that we have. I think when the kind of the part that I hand waved a little bit is taking the reality from a known threat out there, right? So there's kind of that process of you have to be aware of the threat, which comes through, monitoring social channels, news, open source, intelligence. You have to understand the threat, which is where you're actually looking at those research articles, you're kind of getting a sense of technically how that works, and then you're translating that into queries, right? So that part of it, I mean, it's not as cool to watch somebody do, right? So that's that's part of the challenge of doing these things, is like, hey, the reality is that there's a lot of trial and error, right? You're like, oh, let's try this query. Does that work? Ooh, it gets too many results. All right, let's refine that. Let's add this filter. Let's do this thing. We're definitely going to do that on some of these sessions. There'll be maybe a little bit less high energy. I don't know, like I'm just saying. But the reality is like, to get down into that level of stuff, you really gotta do the work, right? That's where the work part of it comes in, is trying something, filtering it out, working through it, seeing what details, what data you get back, and adjusting that, right? So that's where the art of it really comes in. And some of it's just, you got to get in there and do it, right? Like I remember one of my favorite mottos was from Offensive Security. Their motto was try harder, right? I mean, you're like, can I have some help? And they're like, try harder.
Just do better.
Exactly.
If anyone does want to, if we should prioritize something like that are the more advanced, kind of, maybe we'll say boring, not as sexy things with detection engineering, and that is of interest, just go ahead and give a thumbs up or let us know. This is really kind of for the industry, right? This is for detection engineers. If you guys have things that you want to see or want us to talk about, or have people, if you even have a project you're working on that you just want to talk about with other people, let us know. And we're happy to bring those people in or you in to do a Q&A or chat about whatever and kind of do open discussions. So definitely keep us up to date. And as Tim mentioned, we will be sending you out our giveaway. So after each session, we'll have a giveaway. It'll be detections a lot of times, but maybe other times it might be some PowerPoints of best practices templates of how to do reporting, or a lot of different ideas we've been tossing around. But today you'll be getting 4 detections that'll help you with things like, there's a lot of threat actors out there that utilize ingress tool transfer and techniques for infiltration systems within networks. And often that's through spear phishing, exploited software, vulnerabilities, or a lot of other ways. So by transferring the malicious tools into those compromised systems, so once they're inside, they can modify or download files, which obviously, when executed, grant them further access, and that's not good for anyone. So based on some sequence-based approaches and progression of the correlations of the activities, you can find them and effectively triage them a lot faster. And also, you can isolate the genuine threats from the noise. So within those 4 detections, that's what these will be focused on. We'll be giving them to you in a few different languages. So SPL, I believe SQL. If they're not in SQL and you do need them in SQL, let us know. I'm not sure if they're going to be in KQL, but feel free to, once we send them out, to reach back out to us if they don't have the language that you want, and we'll see what we can do. But yeah, 4 different detections to assist you. Feel free to play around with those. There's no other questions. I think let's give it a few seconds in case there is a question, jump on in. If not, thank you all for attending, and I hope to see you in 2 weeks.
Thanks, everybody.